Hi, good morning, everybody. How is everyone this morning? Good? Excellent. I like to hear that. So my name is Mark Agar. I work in Microsoft's sustainability group. I am also Microsoft's representative on the board of directors for the Green Grid. And it is my great pleasure today to talk about something that is near and dear to my heart, and that is the role of developers in IT resource efficiency. Can anyone tell me what that developers, or who is famous for saying that? Anyone that doesn't work at Microsoft? No? So Steve Ballmer is very well known actually for championing the role of developers in basically the entire software industry. That's essentially the most critical link. What's interesting is they've essentially been absent from the discussion in data center efficiency, and I want to rectify that right now. So the agenda today, we're going to be talking primarily about software in data centers. But I do want to give a little bit of a shout out to the important role of software as it relates to client device energy efficiency as a sort of little bit of sort of homework that you can do. Maybe go back to your IT folks and help them make their client environments a little bit more efficient. So a few pointers there towards the end. But I want to start with a little observation. So this is something that Kim Shearer, who is here today, is up the back there, sent me last week. And he said, have you seen this? This is a list of applications that Verizon have put up. That's weird, there's something missing on the page there. Hang on, there's a graphic missing for some reason. That's kind of scary. But yeah, so this is a list of applications. In fact, actually, this is just a subset of the applications. These were sort of what I thought were the most notable apps, where for some reason the developers from these pretty reputable development houses decided that it would be a good idea to keep the screen on all the time while the game is running, regardless of whether you were holding the device. Now, I don't know about you, but when I play a game on my phone, the whole point is that I'm using the screen. And as a result of that, the device will stay on naturally. It won't go off. Yet, these guys, and these are smart people, decided, yeah, we should just leave it on all the time. So if you put the device down and take a phone call, go to the bathroom, whatever, you will come back, and if you forget, your device will be dramatically drained of battery and potentially dead. Now, it's not like these developers don't have these devices and haven't experienced this themselves. They thought that this would be a good idea. I contend that this is a very bad idea, and Verizon agrees with me and recommends that users be aware of this for these particular apps and a lot of others. So this is, the moral of this story is that you really can't trust developers to do the right thing without the appropriate guidance. And that's sort of the key message today. So this is an illustration of poor resource utilization. If anyone's vacationed in Europe, as I did 20 years ago or so, you will have seen this image. You wake up in the morning, it's maybe 8, 9 o'clock in the morning, you look out your balcony window, and you look down at the pool, and all the deck chairs are reserved. And you go, what the heck? Well, it turns out that people of certain nationalities who will remain nameless, at least this was the theory from the British side of the equation, would get up at, probably come home from the bars at like 3 in the morning and put their towel on the deck chair to reserve it for when they got up at noon. This is, I think, what most data centers look like if your servers were deck chairs. And so, essentially here, we need to do some work. And I'm actually going to start collecting a library of pictures like this because underutilization is not a phenomena that's unique to data centers. What I didn't realize when I looked out of the window is that these tourists would essentially grow up to be developers of software for data centers. But yeah. No names. So, underutilization of data center resources is not exactly a new phenomenon. I've been doing some research of this issue over the years, and looking at a decade's worth of reports, you see that essentially, the situation really hasn't changed. In fact, there is actually a trend for utilization to be getting worse. 20% utilization or less than is a commonly cited number. And some individual reports, frankly say that they are probably half that or less. The other challenge is that 15% of the servers are entirely idle, doing nothing, never did anything. They sit there for 3 years and then they're thrown out. Seems like a kind of a waste. The other challenge we have in data centers is that there's a lot of hardware-based redundancy that essentially contributes to underutilization. And the sad thing about, of course, this hardware-based redundancy is, and many times it doesn't actually protect against the failures that you designed it to protect against. Primarily because a lot of failures are actually caused by things out of your control. They're caused by fishing trawlers cutting through fiber optic lines, or the backhoe, or a fat finger, or some poor configuration that was designed into the system in the first place. Maybe even software problems. And so our reliance on hardware-based redundancy, I think, really has to change. And I think the answer towards a lot of that reduction is going to be in the applications themselves. So, hope you're all awake, because it's time for our first live poll. So I'm very curious to see if anybody answers one particular question here, or one particular answer in the affirmative. I suspect they won't. But so if you pull out your devices and navigate to the app, I'm not going to spend too much time on this slide, but we'll show all the results at the end. I've got 3 live polls, so devices at the ready. So very curious to see what your utilization measurement and reporting in your org looks like, if you are doing it at all. So I want to take a little bit of time just to sort of show the power of increasing utilization and the benefits. So this is a chart. I'm sure many of you have probably seen this before. This is from a spec power test. So go up to spec.org, and there's the spec power benchmark there. And there's a whole bunch of new machines, old machines that have been tested to see how well they perform, how much energy they use under load. As we can see here from this particular random sample, we have a base load of 32%. So essentially, you turn the machine on, it's doing nothing. It's using 32% of the power. Now, if we take that utilization study I just mentioned earlier, where 10% load or even 20% is sort of the average, and we increase it up to, say, 70% load, which some people may think is crazy, but I actually think that's quite realistic for the set of servers that you would have on, you're going to get 7 times the output for only 58% more power. So that's the power of driving up the utilization of those idle servers. Having, peanut buttering the load across a lot of servers and keeping them low utilization for security is not a very good use of the resource. And the other thing we want to talk about here is that it's really not just about the operating costs of running the data center. So if you look at resource efficiency, clearly we want to be able to make sure that we reduce our operational overhead, as we measure with PUE. We want to make sure we have the right type of resources. By that I mean making sure your equipment is super efficient, that it has pretty low power idle state, but also scales its energy use proportionally to load. You want to make sure you have the right amount of resources. I'll come back to that in a minute. And of course, you want to make sure those resources are highly utilized, which is essentially what we're talking about here. But the important thing to know is that not having it is actually better than trying to make what you don't need efficient. Right-sizing that infrastructure is really critical. And that's actually where the largest part of the savings will be. If you can avoid building a data center and buying servers that you're not going to use, that's going to be way better than trying to save energy on those servers that you didn't need. So having high utilization of the assets you need is actually good for OpEx and CapEx. And I believe that the CapEx is actually probably the most attractive part of the equation. So if we look at utilization in context, this is a chart that I developed a couple of years ago in a white paper I wrote, which is linked at the bottom there. So I took a base of a sort of pseudo-efficient data center, a 2.0 PUE at the time, which is probably better than a lot of data centers are today. 65% power supply efficiency as a proxy for the IT equipment, and 7% server utilization. I brought that server utilization down low just for a dramatic effect. But as you can see, if you increase if you keep everything constant and just increase or improve along one of the variables, you can see that your overall energy productivity, the amount of energy going into the data center that's actually doing work, doesn't actually improve that much. You go from a 2.0 to a 1.2 PUE, which would be a kind of gargantuan effort for any existing data center owner. You're only going to go from like 2 to 4% productivity, and it's a similar trajectory for power supply efficiency. Now, if you improve server utilization, however, because you're starting from a very low point, you're going to see a dramatic improvement relative to PUE and PSE in terms of how much energy is actually going to be doing useful work. And so that to me was sort of the aha moment as to why the green grid and the industry as a whole really needs to focus on driving up that server utilization number. Now, this is what I like to call my guilt slide. So, I hope you're all feeling bad after this and want to act. So essentially, it's not just about the energy and it's not just about the CapEx. Making servers is an incredibly resource-intensive endeavor. Lots of materials used, all this stuff comes out of the ground, ultimately, drilling big holes and polluting waterways, et cetera, potentially. Those resources are in short supply. The extraction of them can hurt the environment. And of course, ultimately when it gets to the data center, a lot of it's underutilized, but it's consuming lots of energy because it's sitting there idle, powered on, and then it becomes e-waste in a few years. Doesn't seem like a really good investment to me. Now, of course, 2/3 of that e-waste, according to a number of NGO reports, shows up in landfills or is shipped overseas. And if it's shipped overseas, it's disassembled in a hazardous manner, which hurts the people and the environment. So this part here, I don't know that the green grid is really in a position to do much about the other stuff, but the bit in the middle is really where we need to focus. We can actually reduce the negative impacts of electronics manufacturing in data centers in particular by focusing on actually only buying as much stuff as we need and then utilizing it effectively. So, to quote Alanis Morissette, I believe that data centers should consume more energy. Crazy thought. Because ultimately, when you're going to drive up utilization, those servers will use more energy. And so, assuming that you're going to keep your overheads constant or reduce them, you will probably see an increase in energy in the data center. But the advantage is we don't need to build as many data centers. Now, we'll probably need to build more data centers for geographic reasons, latency, et cetera, and redundancy. But we don't need to build a data center here and then right next door a data center there and another data center there when our utilization for the first one is really low. Now, a few of you are probably wondering, well, I thought we solved this problem because we've had virtualization for the last decade or so and it's been fairly mainstream for 5 years. Well, it's helped to some degree. That's undeniable. Certainly, we've got a lot of applications now running in VMs. The problem that I see is that hardware performance is getting so great that it's outpacing the comfort level of developers. They aren't consolidating the ratio that's probably appropriate for the hardware performance. It's just a matter of what people are comfortable with. And of course, coupled with that, the risk of consolidating apps is just perceived as too great. Now, whether it's actually too great or not is highly debatable. But if the applications are not designed for those environments, then I can understand why that is. So this brings me to my point. I don't think that really has anything to do with it. Well, the problem is the applications really aren't being designed to take advantage of this infrastructure. Our developers have the same mindset they did as when they were developing on their own dedicated physical infrastructure. And so what this means is that we're essentially replacing mostly idle physical machines with mostly idle VMs. And so yes, we probably have less machines, maybe. That assumes that the self-service provisioning you're seeing in clouds is not exacerbating the problem of having even more idle machines. But we're not really making any progress here. So what we need is smarter software. That's critical. So there's a couple of dimensions of software which can help towards efficiency. One is making your software more resilient, making it aware that stuff underneath it will fail, and not depending on the infrastructure to be there 24/7, 365. So if you make your application more resilient, you're going to need less hardware redundancy. You'll also mean that you can use commodity hardware, essentially cheaper hardware, doesn't have a whole bunch of extra overhead that costs a lot of money. Now, on the efficiency angle, if we make our software more efficient, we'll get more output from the resources that are running that application, and we'll need less total infrastructure. So ultimately, fewer servers with more output for the energy we put in. So what the essence here is, in order to get lower TCO for our data centers, we have to have better application design. That's absolutely fundamental. So what we're really after is efficient and highly utilized data centers. Efficient is not good enough anymore. So clearly, we need efficiency measurements, because how will we know whether we're improving or not? So Green Grid is doing a good job in that with regards to the facility side. We need to do a better job with regards to the IT infrastructure side, and that's something we're working on, which I'll talk about later. We need that, once we've got those efficiency measurements, we want to bring down our overheads as much as possible. But as you saw earlier, they're not as impactful as perhaps we might thought they were. We need our equipment to be power efficient, no question about it. And now we're getting into sort of the areas that you may not have heard of. So we want a small number of hardware models in our data center. And by small, small is relative to potentially what you have, but the more hardware configurations and models you have, the more complexity you have, the less reusable that infrastructure is going to be. We need common application management fabrics to sit on top of those hardware configurations that applications can then be written to and consume. And there are, and I say fabrics very deliberately because there are different types of application management fabrics that you can consider. For instance, you're going to have a classic compute fabric, you'll have a storage fabric, you may have a database as a service fabric, you may have a big data fabric as some examples. We want the application management fabric to be able to provide small scaling units and have multi-tenancy on any given piece of hardware. So multi-tenancy you can achieve through virtualization, but it may come as a shock to you that most OSs can actually run more than one app on the same OS instance. You don't necessarily need to do that if the applications are coming from the same owner, they can actually run in the same OS instance. We need our applications to be efficient and resilient, and I'll be drilling more into that in a moment. And also we need our applications to understand constraints. I don't believe that we should be building applications that just assume unlimited resources all the time. Applications need to understand whether there are, understand constraints due to failures. They need to understand constraints due to external conditions, and I'll talk about that in a moment. And then I think one of the most critical pieces here is we need mechanisms to be able to utilize the capacity buffer opportunistically. And I have a very interesting chart coming up that will demonstrate that. And then last, and probably least, we want our unused equipment to be turned off. Now, this has kind of been controversial for some time. I actually think that is the last resort, and you would want to avoid that at all costs, because it's much better to be using the equipment for something useful than to turn it off. If you turn it off, that's a waste of an asset. But if, under the worst case circumstances, you can't find anything else for the machines to do, turn them off. And at very least, when you provision servers into a data center, if they aren't planned on being used for weeks or months, turn them off. Don't just leave them running. People seem to think that energy is free when they plug them into data centers. So that middle piece there is what I refer to as fungible infrastructure. And that is really the critical component that's missing from a lot of data centers. So I want to talk about sort of how fungible infrastructure can get used. So this is a completely synthetic chart. I literally just created this in Excel, made some numbers up, just to illustrate sort of how this works. So if you imagine it's the end of the fiscal year, fiscal year ends in June, and you look back at your average utilization, this assumes, of course, you're measuring your utilization, you will see that based on the average utilization measurement, the capacity that you needed to do all the work in your data center, in this case, was about 50%, just shy of it. Now, of course, most data centers will probably be a lot lower than that. I was trying to be generous. Now, but there's a little wrinkle here that at certain points in time during those measurement periods, the utilization actually spiked for a small period of time. And that essentially is going to be the peak capacity you need. So you can't build for your average utilization, you have to build for your peak utilization. And so in this scenario, you need 55% of the capacity. That implies that 45% of that capacity you never needed. So you can view that as excess. Now, clearly, no one's going to be able to figure out what that number is going to be ahead of time. And you're always going to want a little bit of a buffer. But essentially, you can think of that as capacity that you never really needed, even though your load may have been spread across all those servers. So what this means, though, is that the gap, the space between the yellow and the orange here, is essentially what I would call opportunistic capacity to do new work. And of course, you can sort of decide based on your appetite for risk how much of that yellow excess capacity buffer you want to utilize for that opportunistic capacity as well. So if we turn this frown upside down here, and look at what can we use this opportunistic capacity for? Well, the first thing we can do is we can use it for workloads that have what we call non-coincident capacity demand. So if the peaks are, say, in May and June, we saw our peak was in sort of in the middle of the end of the year there, we could actually run sort of our critical workloads. And so as a sort of on a daily basis, you could think of this as an example where you're running your 401k front end during the utilization trough of the stock system. Most people, I imagine, sort of rebalance their 401ks at the end of the day when they're at home, and of course stock trades are happening during the day. So those two workloads could run quite nicely together. Now the other thing you can do is you can run batch jobs. And the nice thing about batch jobs is that most of them don't need to run in real time because they're batch jobs. And so we could run our back-end 401k rebalancing during the trough of the stock trading system, or we could do some big data analytics. And we're seeing lots of examples out in the public domain where people are saying we're using our spare capacity that we have allocated to run Hadoop. So that Hadoop runs opportunistically. They don't have a whole separate set of resources necessarily dedicated to running Hadoop. So if we look at this sort of in more detail, so here's an example of two applications, once again, entirely synthetic data. This is like a particular snapshot, and just imagine this is like the worst day of the year in terms of, or the busiest day of the year in terms of utilization. So we can see here, two different charts. Their peaks are not coincident. So what we can do, if we move those to fungible infrastructure, and notice that each of those applications has like about 100 servers dedicated to it each, we can move those onto the same fabric. And as a result, we could essentially get rid of 45% of the servers, even by adding a 10% buffer. But it doesn't end there, because if we stack those utilization graphs on top of each other, we can see that there's a whole bunch of capacity that's just sitting there underutilized or unused. That actually in this chart is 50% of the capacity. Now, I don't know about you, but if I had something that wasn't used for half the time, I wouldn't think that was a very good use of my resources. And the nice thing about software is that it doesn't care about getting up in the middle of the night to run. You can schedule stuff at any time. It's not people. So we can actually be smart about the way we schedule jobs to do work that isn't real time. All right, so second live poll. So hopefully I've impressed upon you that fungible infrastructure is a critical component of driving up utilization. In fact, it's probably, it's a prerequisite to driving up utilization. So I'm curious how fast your organizations are migrating their workloads to fungible infrastructure. And so I will skip to the next slide. All right, so I'm actually doing really well on time, so I have lots of time for Q&A. So when developers are building efficient, reliable, resilient applications, that's actually a typo there, There's actually a nice Venn diagram here where you can do stuff that actually contributes to being both efficient and resilient. So if we just look at the efficiency side first, that's like unique to efficiency. Clearly, the first thing we want to do is run on fungible infrastructure. Hopefully, you've got that message by now. We also want to be able to measure and test the performance of our applications, both at high throughput and probably critically at idle. What we don't want to do, especially when we're running on fungible infrastructure, we don't want our idle applications to be consuming a lot of resources unnecessarily. So we want to make sure that when those things are done, they're really done, and they don't just poll in loops for no good reason. And then the other thing we want to do is we want to be smart about when we schedule those workloads to maximize the overall capacity utilization of the fungible environment. On the resiliency side, the first thing we should do before we try and spend a lot of money investing in resiliency is figure out how resilient does this application need to be? Does it really need to be 5 nines? Is this something that if it was down for an hour or two a day, or even a week or a month or a year, does it really matter? Will people live? And there is a cost associated with making anything resilient in hardware or software. So that's a critical thing that developers need to really do, along with the folks that are ultimately asking for the application. Now, once you've made that decision, and assuming that you do need your application to be resilient to some degree, you should start assuming that all the components will fail that that application is running on and could be replaced at any time. Now, there are going to be certain things that you consume as a service, for instance, a database as a service, which probably have their own level of resiliency built in and provide a certain SLA. And so depending on the SLA that they provide, you can sort of make some assumptions. But particularly for the actual compute infrastructure that you're running on, you should just assume that that compute infrastructure will just disappear from underneath your feet. Stuff fails. Hard drives go down, memory goes bad. You can't assume it's there, and no amount of hardware-based redundancy on any given machine is going to really give you a guarantee that that machine will never go down, because it could just be turned off accidentally. And you should also assume that all the software components in your application may disappear from time to time. And so, and one way to do this, and this is something that we, famously hear Netflix doing a lot of, and they've actually got some really good information actually up on the web, some good presentations they've done, is to frequently test the recovery process. And so Netflix has a thing called Chaos Monkey. In fact, they have this whole suite of tools called the Simian Army, which go around and kill applications and see, just to test, how the user experience and how the rest of the system actually deals with that event. And, and ultimately what you want to be able to do is make sure that the user doesn't have a poor experience as a result of it. So when we combine these two things together, we see that there are a certain number of actions that developers should take that contribute both towards efficiency and resiliency. So automatic scaling, which has sort of been my big, I don't want to use the word jihad, but I will. Just trying to get applications or developers to think about the importance of scaling their applications up and down. And essentially what we're doing here is we're scaling up for resiliency. We don't want to assign a set of resources and then think, yeah, that's okay, and then suddenly there's what we call a /dot event where your application or website gets very popular, and then you're out of resources, and everyone on the site gets a really bad experience. You want to be able to scale up. That's just as much a reliability issue as anything else. And for efficiency, we want to be able to scale down when that event's over. Scale down at night, then more opportunistic jobs can run. We want those applications to be responsive to those availability constraints. I mentioned this earlier, but one other constraint that you might have as a data center, this might be something interesting for the Green Grid to consider, is what happens if there's a demand response event and your data center is signed up to shed load. Now, historically, you could just say, well, we'll just fire up our generators and then produce a bunch of pollution as a result. Or you could send a signal to the applications that say, hey, all that non-critical stuff you're doing right now, stop it. You can wait an hour or two until that demand response event is over, And as a result, you're going to have less power that you need to generate from your generators, and potentially you have to fire up your generators at all. That capacity constraint could also literally be a capacity constraint within the data center. There might be something more important than your job running that we need to get done now, and we're just going to ask you to just back off for a little bit. But what's important, though, is that in those situations, we need to be able to provide the user with an error-free experience during that failure or constraint condition. That's actually probably the biggest reason why we have over-provisioned our applications, because we're so terrified that the users are going to have a bad experience, because the software is not really designed to do anything else other than fail if everything is not 100% correct. So how do we break this cycle? So as you can see here, if we provision our applications for peak load, and typically it's peak plus a substantial buffer, the developer isn't going to invest in resource efficiency. There's no point. If I've got all the resources I need, why would I ever try and scale up or scale down? And as a result of that, the operations folks aren't really going to have any insight into what the application is doing, because the developer has not spent any time instrumenting their application. Now, we can break this cycle if we put these applications on fungible infrastructure. So this means that we can now provision our applications for the anticipated load. Now, it's important to provision for anticipated load, because you don't want to be behind the curve, behind the demand curve. But you don't have to be so far ahead of the demand curve that you have a whole bunch of waste. This is going to mean that the developer now can invest in resource efficiency, because there's potentially an incentive to do so. And then now operations actually has insight into what the applications are doing. But there's a catch. The challenge is, if there's no accountability for that data resource consumption, then I'm just going to do the same thing as I always did. Why spend the effort? If I never see the bill, I'm just going to provision my applications for peak, even if they're a bunch of VMs. If my units of consumption are very coarse-grained, so my IT department charges me for a server for a year or a virtual machine month, why would I scale up and down every day? I'm going to have the same bill at the end of the month regardless. And if I never see the bill as the person who's consuming the resources, and my CFO just pays it automatically with no questions asked, then clearly that isn't going to give me any incentive to do anything different either. Now, there's a little example of how things can change with the right incentives. So if you look at public clouds, and this is true of Amazon and Azure and Google, they're all charging based on the resources you use on pretty small-grained units. And so with that usage-based billing, customers start to closely manage the costs. Now, what typically happens is that they don't manage the costs, and then their boss gets a bill, and he looks at the bill, and he comes out of his office and screams down the hallway, "Who the hell has got all these VMs?" And then things change. So it is a learning process for everybody. But as a result of that angst, because now they're concerned about the bill they're going to get the next month, you actually end up with an ecosystem of tools being developed to help those customers manage those costs. And we're seeing that both the ecosystems are developing on the cloud platforms as well as third parties. And this means that developers can now actually design their applications to use resources effectively much more easily than they could have done if they just had to develop those tools themselves. So this is a chargeback maturity model that actually Microsoft has adopted, and this is something that the field goes and evangelizes, Microsoft's field goes and evangelizes to customers now, in terms of how well are they actually managing their resources based on their chargeback. So on the basic end of the scale, essentially it's free to use. There's no chargeback, and that is essentially going to be chaos as far as resource utilization is going to be concerned. When you move to the right, we get a little bit more mature. You'll have a capacity-based charge. So a dual proc VM. Now, how granular that is a big question. The next phase would be sort of abstracted use. And so a VM hour. We're going to charge you for every hour you use this VM. That is a great incentive for people to say, oh, I'm just going to scale my application down at night. Why incur the costs unnecessarily? And sort of the holy grail here is to actually get to sort of a dynamic model, which frankly very few people have got to, where you're actually billing people on the actual amount of resources they use at fine-grained levels, like CPU minutes. And so this is something that potentially could show up in DCMM, but this is something we can discuss later. All right, so last live poll. So what methods, and I'm actually not sure whether we can do multi-select, so just pick the one that applies most, I guess. What methods does your organization use to drive effective use of your data center IT infrastructure? So I'd be very interested to see the results of that. All right, so we're done with data centers at least for now. So I want to just talk a little bit about the PC client environments. So as you might have guessed, PCs are actually idle for even more than servers are because you sleep. You aren't using them all the time. They're either idle and on, which has been a case with a lot of desktop environments, or they're idle and off. But either way, they're not being used and doing any useful work. The sad thing is that even today, the fact that Microsoft and Linux and Mac have been shipping power management on by default, our telemetry shows that many customers are turning those features off. There's a whole historical set of reasons for that. People didn't trust it. I assure you today that sleep is probably as reliable, if even not more reliable, than most features you use in any piece of software. There's been a lot of effort focused on doing that because ultimately people want their batteries to last all day, and if the machine doesn't sleep, that can be kind of tricky. The other challenge is that sleep and low power idle, and this is a problem also on server for the idle part, is undermined by the applications. These things keep the applications away, because I showed you at the top of the deck, even on the mobile devices where it's really apparent that I have a very small power energy budget, applications are still undermining power management of the platform. So what do we do about it? Well, the first thing I think that you need to do if you have a large PC client environment is deploy centralized PC power management. You aren't going to know what's going on otherwise. And this way you can actually set out policies for when machines sleep, when displays go off as well. And most systems will let you do sort of multi-tier plans where a more aggressive plan, say, kicks in the evening when people aren't here in the office, so that their machines will go to sleep sooner. You want to be able to monitor for the PC insomnia problems and use the diagnostic tools of those power management systems to determine which applications are causing machines to stay awake. This is, there's actually a relatively short list of frequent offenders, and there's an incredibly long tail. I mean, it's just, if I listed it out on a piece of paper, it would literally go out of this room and probably into the next building. Reducing display timeouts. This is a little pet peeve of mine, but I don't know why your monitor needs to stay on for 20 or 30 minutes after you've left the room. 5 minutes should be ample. Most applications that require the display to stay on will request that the display stays on. So if you're watching a movie, YouTube video, whatever else, the display will stay on while you're watching it when you're not interacting with the keyboard and mouse. If you've left the room, why keep it on? And another emerging trend here is that we're seeing people replace any secondary devices they have. This is particularly pertinent in development environments where you have developers with like a whole raft of machines under their desks. Replace those with virtual machines. That way you can share the resources across many developers, and you're not actually contributing to a whole bunch of power AC cooling overhead in the building that those are in. In fact, sort of taking that a little step further, if you have lab environments in your office building, your AC in that building will have to run continuously 24/7 even when there's no one in it. So the more PCs and servers you can move out of those office buildings into dedicated facilities, such as data centers, the better off, the more energy you'll be able to save on your AC bill, because that AC will be able to ramp down at night. All right, so we're pretty much done but with this presentation, but not with this topic. So we need your help. We need you to help us, A, develop some guidance around how we can utilize our clouds more effectively, and also how we can measure how well we're using our clouds. And so we have 2 sessions this afternoon, 1 p.m., 2 p.m., back to back. I'll give you a bathroom break if you're nice. So saturating clouds. So we've got a few folks who are going to help us, from a guy from Verizon and EMC, who will help me moderate this panel around what are the techniques, incentives, governance models, chargebacks, application designs, you name it, that we can leverage to actually help us extract the most value from our substantial investments in IT infrastructure, particularly private clouds. This could actually also extend to public clouds as well, given that you'll get the bill anyway. And then also, John Pfluger and I are doing a round birds of a feather session on utilization, IT utilization. How do you measure it? How do you report it, et cetera, et cetera. So please come. Apologize to the competing sessions. All right, and so beyond that, though, we have an AR activity request right now for developer practices and incentives in the cloud. And Kim over there, raise your hand again, Kim. Please go see Kim. Stand up, Kim, so people can see you. Please go see Kim if you're interested in contributing to this work. That's the best promotion I could possibly give you. And then the other thing that we've got going on is some data center resource intensity metrics, which Roger Tipley is going to drive, aren't you, Roger? Which we'll hopefully have something in there around server utilization. All right, so let's take a look at the live poll results. We'll do that quickly, then we'll have about 10 minutes left for... All right, so state of utilization measurement. Okay, so actually, no, see that. My binoculars here. All right, 44. So we measure, report, and tell. That's actually pretty good. Very good, 44%. We don't do anything. Actually, no, oh, everybody's doing it then. That's great. So actually, that's gratifying. I didn't notice when I was doing these, I had considered asking you what your utilization levels were, but I figured that would be a little too embarrassing. So I spared you that. So, but that's good. It's good to see. So most of you have sort of a general sense of what's going on. How fast are you migrating? Steady progress. That's good. Don't know. That's encouraging. People are getting the benefits. Not a priority. I'm sorry. 7.5%. That's hopefully this will help you change that perception inside your organization. 5% as fast as we can migrate them. Excellent. All right. And then so what methods do you use? So actually to VTM, were you able to do multiple choice on this? You were? Yes? Actually, Michelle says no, everyone says yes. So yes, okay, I'll trust the audience. Sorry, Michelle. All right, so utilization reporting, not surprisingly, that's as high as it is, given what we saw on the previous charts. Chargeback, that's good. Oh, interesting that more people are doing chargeback than showback. I actually hear a lot of people talking about showback because they're kind of, I don't know, I guess, shy to charge people money for the resources they use. Incentives, yes, developer guidance, is that? Oh, it is there, okay. That's actually, it's higher than I thought that would be, so good. Well, I look forward to spending a little more time thinking about those results. All right, well, I think we are done. So we've got 9 minutes and 52 seconds left for questions. So thank you very much, and I'll take your questions. Gentleman in the front here. Yeah.
All about scheduling your applications and stuff. And what happens is that there's transitions that we go through, mainframes to mini computers,
Yep.
distributed computing, now to x86 cloud type stuff. And each time you need a new control fabric that will help alleviate these problems. It's really about, scheduling and management, and the tools never keep up with what's going on.
Yep.
Also, there's also always the legacy information, legacy applications that people can't take the time to go through and redo, and they won't live on that fungible fabric. So
right.
you present a kind of best case scenario, And yes, the big IDCs can go off and do that. Netflix, it's all
Yep.
web-based. It can do that. But a typical enterprise is going to have a lot of trouble adopting to this. So I would say, best practices for moving forward is something that you look at, but nirvana shall never be.
You raise an excellent point there, and I'm very glad you brought it up because it's something I've talked about in the past. There's going to be your classic applications that sit around for like decades. We've seen that in the past. That's not going to change. My sense is don't sweat it. Just let that live, let it run inefficiently. Eventually it'll get replaced, if it does, by something else. But there are more new applications being developed today, and we'll have more new applications in 10 years than we probably have right now. So that best practices really applies to everything that's new and everything that's getting a major overhaul. But you're absolutely right. I mean, you're going to have a hard time, convincing somebody to take, an application that hasn't been touched in, a year, let alone 5 years, to go back and invest in this if it's not considered like, something that's going to have a lot of growth. It's a sunk cost, essentially, at that point in time. But no, you raise a very good point. And I like the fact that, you got on the fact this is what we did on mainframes. It's, I'm old, I have enough gray hair that I sort of remember reading about that in college.
It's really about how do you constantly do that upgrade of management tools to help make these problems easier to solve.
Yeah, so the question was about should the green group be focusing on the management tools? So yes and no. So yes, I agree with you, but it's critical that developers use those tools and the applications are written to take advantage of those management fabrics. You can put your application on Amazon or Azure or whatever platform you choose, and you can provision it for peak. And if no one asks you to do anything different, that's the way your application is going to sit. And even though your application may be completely stateless and could easily auto-scale, you just may never do it. In fact, that's actually what happens for the majority of the time because developers are bringing their historic being like, server, PC server era development designs to the cloud. And the cloud is an opportunity for that change. And that's what we need to move forward on.
In the mainframe, it was included.
Exactly. Yes,
in the cloud,
you're right.
It's not.
Well, no, actually, so it is included. So it's just not. You don't have to use it. It's not required. So Azure has auto-scaling capabilities. Amazon has auto-scaling capabilities. Google, App Engine. These all things have auto-scale, but you don't need to use them. So maybe it was slightly different in the mainframe days, like you were forced to use it because the compute cycles were so expensive that you would be fired if you didn't. Today, unfortunately, the cycles are relatively cheap compared to what they used to be. But as a impact on resource utilization, it's still as bad, if not worse, because of the sheer scale that we're at now.
Yeah.
Further questions?
Mark.
Oh, there we go, yes.
Yeah. Thank you for the presentation. I have 3 comments, and I have a feeling they are going to be long-winded, so I'll just introduce 3 things.
Oh, they took the chairs.
First of all, you showed the spec power curve. Have you seen the spec power curve when you have virtual machine, at least 4 virtual machines on the machine?
Not consciously. I may have seen it, but I wasn't aware necessarily.
So I have done this multiple times. I can tell you that curve would get incredibly bad.
Right.
So what does this mean? What this means is, if you think about the efficiency, then the notion that you have a host OS and then applications on the virtual OSs, you probably are better efficient by having on a native machine to run the applications. Yes. Now, then if you want to move the applications, there is an overhead of migration. So instead you would start thinking, okay, maybe I will have redundant machines to running same application and to do the load balancing. Again, this is, as soon as you do that, your utilization picture changes.
Yep.
That's one comment. The second comment is, when talking to several end users, what we found out is not only the applications, but there is an issue with the drivers. And why this is important, because for the applications as well for the drivers, they are validated for certain builds of the operating system. And somebody comes up with a new application, they're running on new OS, but some applications, they want the old OSs because they are not validated, and customer, they don't want to take a chance. So this creates a heterogeneity itself and not easy to support in the environment. Right?
Yep.
Yeah. So I think, I forgot my third point, but.
Yeah, no, I understand. I mean, in a platform as a service, environment, you don't get to choose your OS. And that's essentially that's the goal. You abstract the application away from the OS, but you're right, the dependency stack creates a lot of problems with regards to efficiency, particularly on PCs. And
the third point I just remembered, the utilization charts that people see, as far as I know, most operating systems look at the average utilization 6 times an hour, 60 minutes. Now, I have done some experiments where I really had to twist arms to look at just 1 or 2 servers to collect the utilization every 1 second. It's amazing how the chart would change.
Right. Yep.
This is where the issue about having some headroom for excess utilization, I mean, your equations start changing over there. Again, I'm not saying this is universal true for everything, but for many cases, one of the things I think we need to figure out is how do we start accounting for utilization at a smaller granular level to comprehend the impact on performance.
Yep.
Now, there is a challenge with that. When I did that, there is an impact on performance as soon as you start doing every 1 second.
Right.
So.
No, absolutely. Yeah, and so clearly the sampling frequency is a critical part of measuring utilization, and you don't want to miss that peak that is twice as much as what you're seeing in your utilization reporting. So please join us on the utilization session. Yes.
Mark, great presentation and awesome topic. It seems to me that what's happening at the university levels, because the up-and-coming developers, our son started at college with computer engineering, and I asked one of the professors, do they do anything about code efficiency in the classes? Do they study that at all? And he said, no, they don't. Not even on his radar. So
right.
I was pretty shocked.
Yeah.
So do you know of anything that's going on at the university?
I have seen a number of different attempts to get, students involved or sort of more focused on efficiency. Generally speaking, though, the topic has been what I call IT for green. So let's do something that helps people be more sustainable and more efficient, as opposed to making the code itself. The challenge is, of course, what we're talking about here is an attribute of the code, not the code itself. It's actually a relatively small design point, in the grand scheme of the application design. But it's obviously critical, and if you do it early enough in the design phase, it really isn't a problem, and actually is going to help make your application more resilient because you'll understand it better in operation. But yeah, in terms of making it a discipline for developers, I think we're behind the curve, and it's probably an opportunity for Green Grid to sort of inject that into the discussion. Okay, we're out of time, so thank you very much. Appreciate it.